Today we're going to look at confidence intervals and significance test for the difference of two proportions. But I'm starting with an example of an experiment. Would being part of a support group that meets regularly help people who are wearing the nicotine patch actually quit smoking? Design an experiment that could be done to find out. So you might take a minute to go ahead and design this experiment. So you might want to pause this video. Okay, what you might have come up with, and we don't have any numbers of how many people were in the group, but we do have that we were given volunteers. So we know that those volunteers could be randomly assigned to one of two groups, where one group would receive the patch and a support group meetings. The other group would receive the patch only, and then what we would do is compare the percentages who actually quit smoking. So that's how we could design an experiment. So let's suppose now, here's the whole problem, a county health department tries an experiment using several hundred volunteers who were planning to use the patch to help them quit smoking. The subjects were randomly divided into two groups. People in group 1 were given the patch and attended a weekly discussion meeting with counselors and others trying to quit. People in group 2 also used the patch but did not participate in the counseling groups. After 6 months, 46 of the 143 smokers in Group 1 and 30 of 151 smokers in Group 2 had successfully stopped smoking. Do these results suggest that such support groups could be an effective way to help people stop smoking? Now I'm going to define a couple of our groups here. I'm going to let P sub 1 represent the proportion of the population who quit smoking with the patch and meetings. Now, what you might want to do at times is actually, instead of using a 1 and a 2, instead you can use a letter for a subscript. For example, you might say P sub S for support groups or something, and P sub WS without support, or I don't know, that could be a little confusing, but you can use subscripts that are not just numbers. If you do that, sometimes you can get away with not defining what your two groups are. If your subscript, we could put P with, you could actually spell out the word support. You don't have to have just a single letter or number for your subscript. So if you can kind of define your group by using a subscript, then that's a good thing to do. I didn't do that here. So I have my two groups. So then X sub 1 is going to represent everything from that group in the that quit smoking with the patch and the meeting. So I defined X sub 1 as 46. Those are the people who quit smoking out of the 143 who had agreed or who were assigned to the group of using the patch and being in the support groups. X sub 2 were the 30 people who quit smoking from just using the patch alone. So I come up with these two different P hat values, one from each of my two groups. And what we're looking at, is there a difference between the two groups? And that's what we want to know. Now, I need to check some conditions, and these are in your textbook on page 497. The first condition would be that the data in each group must be drawn randomly from the population or generated from a randomized experiment. So it's important that we still have that randomization. The second thing is the sample size has to be less than 10% of the population. And clearly there are a lot more smokers in the world than what we, in our group, that condition will be met. Then for the next one, each group has to be big enough. So you do have to check not just N times P greater than 10, but this time it's N1 times P1, and N1 times Q1, and N2 times P2. You have to check all four of those and make sure that each group is big enough. And this other one, which is extremely important, each group must be independent of the other. Now, up here, when we talked about randomly, that would ensure that each subject was independent from the other subjects. But in this, when you have two proportions, it's important that each group be independent. And the reason why is remember that when we had two different populations or two different groups, and we wanted to talk about their variances. Well, remember that even if this was subtraction down here, variances always add. But in order to do this, they had to be independent. And that's the same formula here, because this is the variance of, instead of x minus 1, x minus y, it's going to be p hat 1 minus p hat 2. And so in order to use this formula, which we need to use, the two groups must be independent. So this is what the formula is going to look like. We're going to use a p hat and a q hat in our formula, which means this is going to be called the standard error for the difference of two proportions. So here's the formula. You will find this formula on your yellow sheet. So you might want to take a look there on the yellow sheet on page 2 that I gave you. But again, our conditions require two independent groups. So for our problem, let's make sure the conditions are satisfied. Well, we are told that subjects were randomly divided into two groups. So this should ensure that each subject is independent from the others. And because they're randomly divided into two groups, we also should end up with each group should be independent from the other. So our randomness, our independence is satisfied. But again, make sure you notice the difference between my two statements about independence. Each subject is independent from the others in their group, but each group is independent from the other. So that's important. Our two samples combined is 294, and that's definitely less than 10% of all smokers. We had 46 in the first group who stopped smoking, which means 97 did not. 36 in the second group stopped smoking, which means 121 did not. All of those things are greater than 10, so that means that our conditions have been met. Now there's two types of inference we can do. One of them is a confidence interval, the other is the significance test. So just like for single proportions. We're going to start with a confidence interval, and we're going to do a 95% confidence interval for the difference of two proportions. You have this formula on your yellow sheet where we're told a confidence interval is the statistic plus or minus the critical value times the standard deviation of the statistic. And our statistic is the difference of the two sample proportions. Since we're doing a 95% confidence interval, my z-star value is 1.96, and this is going to be what I use for my standard deviation of my statistic. And again, this is on your yellow sheet, so you wouldn't have to memorize it. If I substituted in the values, this is what I get. So be careful to use the actual values. Don't round them here. So 46 out of 143 would be my p hat for the first sample. And so I would leave it like that, although I'm going to use my calculator to help out here. If we go on our calculator to stat and test, and we have some options here, we are looking for two proportion z interval. So here's the two proportion z test. We're going to come back to that one later. Make sure you don't do the two sample. We're doing two proportions. So here it is. Two proportion z interval is what I'm going to choose, and always name it what you're going to do. Now I had done this already, but you're going to enter in the information. So 46 out of 143, 30 out of 151. I do want a 95% confidence level, but I could change that if I was asked for something different. And then hit calculate. So you can see I'm given my interval. I have my p hat 1, p hat 2, n1, and n2, so I'm given all those values. So let's think about what this means. Here's my interpretation, or my conclusion. I am 95% confident that the proportion of people who quit smoking with the patch in the support group is between 0.02 and 0.22 greater than the proportion of people who quit smoking using the patch alone. Now that would be my conclusion. It is in context. One of the things that you'll be looking for in your when you're comparing two proportions is sometimes what will happen. Now in this case, all my values were positive. Remember how this was calculated? We subtracted the proportion with the support group minus the proportion that didn't use the support group. So sometimes when you subtract those two values, you'll end up with crossing over 0. And when you find 0 in your confidence interval, that means there may have been no difference between the two proportions. So typically you're looking for 0. Now in this case, 0 is not included. All my values are positive, which means that I'm 95% confident. Since I'm 95% confident that I have captured the true proportion, then that this is one of the intervals that would capture the true proportion, then that's, and I don't find 0 here, and all the values are positive, then this would provide pretty strong evidence that the support group really does help. So again, you might want to kind of go over this interpretation that I used again, or for my confidence interval. Now, if you were asked specifically what is the meaning of 95% confidence, well, it's the same meaning that we had before. In repeated sampling of this kind, 95% of the confidence intervals created will capture the true difference of proportions between these two groups of smokers. So I still have some context about the smokers, but again, the 95% confidence is exactly the same thing that it meant for when we were doing one proportion. It's just my conclusion was a little bit different. And when you're comparing two proportions, remember, really, you're looking for 0 to be within there. Because if 0 is in that confidence interval, then that means there might be no difference between the two proportions.